Dear students, let's see this question. Here is saying that an incompressible liquid is kept in a container having a weightless piston with a hole. So here this one is a piston and here some small hole is there, and up to here the liquid is there, and in this hole a capillary tube is placed. A capillary tube is placed. Try to understand. A capillary tube of inner radius 0.1 millimeter. A capillary tube of inner radius 0.1 millimeter is dipped vertically into the liquid through airtight piston hole as shown in the figure. So we already discussed, right? So it will be aerated. There is no chance to escape. And the air in the container is isothermally compressed. So air is compressed here. Here piston, right? Through the piston, we are applying some pressure down. When I am applying pressure, then it will apply pressure on air. When it will apply pressure on air will apply pressure on liquid. Air will apply pressure on liquid. Due to that, what will happen? The liquid will enter into the capillary tube. Clear? The liquid will enter into the capillary tube, and the height of the liquid will increases, depends upon the pressure. So he is saying that the air in the container is isothermally compressed from its original volume V0 to 100 by 101 V0 with movable piston. Considering air as an ideal gas, the height h of the liquid above the liquid level will be. So here he is saying that from the liquid surface, how much h, what is the value of h he is asking, right? So he is given the values. Surface tension is given, and pressure is given. PA, atmospheric pressure is given 10 power 5. Density of the liquid is given 10 power 3, and radius of this tube, radius of capillary tube is given 0.1 millimeter. From this one he is asking, right? He is asking height. That too, height in centimeters he is asking. Centimeter is asking. We'll try to understand. See here see, in this situation here, try to understand. This is the level, and tube is this one. Tube is this one, and this one will be a piston. This one will be piston, right? And liquid will be like this. Liquid will be like this. The meniscus will be formed like this, right? So I will try to draw here. If you see the outer part liquid will be this one. Clear? Now try to understand. So at this point, I will write P0, or we can write P0 I will write. So inside I will write here it is Pi. So here sir, liquid this one. So I will write here PS, pressure on the surface. Now I will try to find out the expressions in between the two, and after that I will try to find out the value. Clear? So see here in this question what is given again. Just note down here. I am writing. The column height is given. It is h. Clear? So now at this point the pressure is Pi. At this point what is the pressure? Pi. So at a depth of h. So at this point what will be the pressure? The total pressure. Pi plus h. Pi plus h. So I will write here Ps is equal to Pi plus rho GH. So Ps minus Pi, which is equal to rho GH. I hope you understood, right? Try to understand. At this point pressure I know it is Pi. Again I am going deep to add H. So rho GH. So Pi plus rho GH, which is nothing but the surface point Ps. Clear? And second one, see, I want to find out the relation between outside pressure and inside pressure. At this point pressure and at this point pressure I am going to calculate. So in order to calculate the pressure, try to understand, the surface is like this. Surface is curved. So where there is a curve, at that point pressure will be more. At that point pressure will be more. That's why now. So now if I am saying that a layer is there, a layer which separates two mediums. A layer which separates two mediums. If the layer is like this, then both sides pressure remains same. If I am applying more force or more pressure, then the layer becomes curved. So in this region pressure will be more. So here pressure will be less. So if you see this situation here, outside pressure P naught will be greater than the inside pressure. So I will write P naught minus Pi is equal to, this is nothing but excess pressure. Excess pressure, we already discussed in surface tension. Excess pressure delta P, which is nothing but P naught minus Pi is equal to 2T by R. 2T by R. Clear? I got two relations. Just I will find out the value. See here, I will do minus, plus and minus. So Pi get cancelled. Pi get cancelled. So PS can written as PS minus P naught is equal to rho GH minus 2T by R. PS minus P naught is equal to rho GH by 2T minus R. But still, I don't know the value of PS. I don't know the value of PS. PS is nothing but the final pressure, right? Further again, he is given one clue that here whatever the compression is there, that compression is isothermal compression. Which compression it is? Isothermal compression. In isothermal process, temperature remains constant. Temperature remains constant. If temperature remains constant, we know PV is equal to nRT. So P1 V1 is equal to P2 V2. P1 V1 is equal to P2 V2. I will apply. So here P1 V1 is equal to P2 V2. Clear? So here P1 V1. So initially what is given? Initially normal air is there. Correct? So I will write PA. And V1 is given as V0, which is equal to P2. Final pressure is. So we are applying some pressure. That's why it is PS. So V2 becomes 100 by 101. It is V0. Clear? And this side V0, this side V0 get cancelled. So PS can be written as how much it is? PS can be written as 101 by PA into 101 by 100 into PA. So PS is equal to 101 by 100 into PA I got. So I will substitute this value, then I will get the value of H. But because every value is given. Clear? Now see here, just I will substitute here. Here I will arrange the question. See. See, we know that PS value I got 101 by 100 into PA minus P0 here. P0 is nothing but the atmospheric pressure, which is nothing but PA. Clear? P0 is nothing but the atmospheric pressure, which is PA, which is equal to rho GH minus 2T by R. 2T by R. So all values are given. We will try to substitute. We will calculate. See here. So here we will do. Here it is 101 minus 100 by 100 into PA, which is equal to rho GH minus 2T by R. So here it is PA by 100, which is equal to rho GH minus 2T by R. So what we are going to calculate? We are going to calculate the value of H. So substitute the values. PA value is given 10 power 5 by 100, which is equal to rho density 10 power 3, G gravity 10, height what we are going to calculate minus 2T. What is T? T is 0.075 upon R is given 0.1 millimeter, 10 power minus 3 meter. Clear? Now substitute here. So here 2 will go. Here 10 power 3 is remaining. 10 power 3 is remaining. 10 power 3. And here it is 10 power 4 H minus. Here it is, we will write 2 into 75 into 10 power minus 3 upon 0.1 into 10 power minus 3. 10 power minus 3, 10 power minus 3 cancel. So here 10 power 3, which is equal to 10 power 4 H minus. So here 275 means 150 into here is 0.1, 10 power minus 1. If 10 power minus 1 will go up, so it will be 10. So directly I will write this 1500. Correct? So here 1000 is equal to 10 power 4 H minus 1500. So this 1500 will go this side. So 10 power 4 H, 10 power 4 into H is equal to 1000 plus 1500, 2500. 2500. So here I will write H is equal to 2500 into 10 power minus 4 meters. 10 power minus 4 meter. But he is asking in terms of centimeters. So here h is equal to 2500 into 10 power minus 4 into 10 power 2 centimeters. 10 power 2 centimeters, right? Clear? 10 power 2 centimeters. Then what will we get here? So these two and this one will be cancelled. So h is equal to 25 centimeters. So this will be the answer. Clear? I hope you understood, right? If any doubts are there in this, if I am teaching now, I am teaching here. So if any line, if you got any doubt, please comment. So I will try to explain. So no need to worry, right? Thank you.